Hi, Saris. My name is Fernaldine Arlauraga from BSFT1A. My topic is Avogadro's number. So, we will tackle the Avogadro's number with the contents. First is the introduction to Avogadro's number. The second is the mathematical and scientific significance. And the third is the application of Avogadro's number. So, and the fourth is the common misconception and clarification. And next is the solving problem using Avogadro's number. And the last is the summary and the review of the Avogadro's number. So first, for the introduction to Avogadro's number, what is Avogadro's number? So the definition of Avogadro's number is the symbol Na equals 6.22 times 10 raised to the power of 3, 23 mole negative 1. So define how many entities are in 1 mole of a substance. Constant for all elements and compounds. Avogadro's number is a constant that represents the number of individual particles like atoms, molecules, or ions. In 1 mole of a substance, it's the value approximately 6.022 times 10 raised to the power of 23 particles per mole. This number helps chemists understand and calculate the quantities at the atomic and the molecular mass level, standardizing how we count extremely small entities across all elements and compounds. So the next is the mathematical and the scientific significance. So numerical value and the notation. So from the scientific notation of Avogadro's number, so the Avogadro's number is the 6.022 times 10 raised to the power of 23. They uses the scientific notation to represent the most extremely large quantity efficiently, essential for precise using to calculate for chemistry and physics, while the comparison to other large constant is the Avogadro's number same at 6.022 times 10 raised to the power of 23. It is more larger than other constant like the speed of light or Planck's constant. It's highlighting its critical role in measuring the microscopic particles. Part 3 is the application of Avogadro's number. So here we can see that the calculating numbers of atoms and molecules. So in short, Avogadro's number helps to calculate the exact number of the atoms or molecules through the given amounts of a substance. And the balancing and chemical equation naman is ito yung tinutulungan nilang using Avogadro's number. They can balance the chemical equation by giving the relating moles of the reactants of the products and ensuring the correct number of the atoms and counted for reactions. Third is the molecular and atomic scale measurement. So, dito na yung they calculate the molecules and the atoms in the given substance to enabling accurate measurement and the analysis at the molecular and atomic scale in chemistry. So the next is the definition and the value. Avogadro's number is 6.022 times 10 raised to the power of 23. it representing the quantity of the particles in mole, crucial for linking atoms to measurable amounts in chemistry. So, importance in chemistry. Avogadro's number is the crucial chemistry as it links atoms to measurable quantities, allow precise calculation in reactions, and helping scientists understand the composition of substances accurately. Third is the historical background. So, Avogadro's number introduced by Amedeo Avogadro in 1811 helped scientists to understand the number of the particles in a mole, crucial for studying chemistry at atomic level. So, the definition and the value is the the Avogadro's number 6.022 times 10 raised to the power of 23. It represents the quantity of the particles in a 1 mole. So, from the importance in chemistry naman, so it's a very crucial in the atoms to use to measure the quantities. It also allowing precise the calculations and helping the scientists to understand the composition of substances accurately. So, from the historical background naman, Amadeo Avogadro is the one who introduced the Avogadro numbers in 1811. So, he helped the scientists to understand the number of particles in 1 mole, which is very crucial for studying chemistry at the atomic level. Next part is the part 5. It is about solving problem using Avogadro's number. It's the common problem types. First is the calculating number of the particles. So it is multiplying the given moles by Avogadro's number 6.022 times 10 raised to the power 23 particles per mole. This converts moles into individual particles. So, calculating numbers of moles naman, it is divide the given of the particles by Avogadro's number 6.022 times 10 raised to the power 23. This converts the particles to moles in stoichiometric problems. So the next is the mathematical and the scientific significance. So numerical value and the notation. So from the scientific notation of Avogadro's number, so the Avogadro's number is the 6.022 times 10 raised to the power of 23. They uses the scientific notation to represent the most extremely large quantity efficiently, essential for precise using to calculate for chemistry and physics, while the comparison to other large constant is the Avogadro's number same as 6.022 times 10 raised to the power of 23. It is more larger than other constant like the speed of light or Planck's constant. It's highlighting its critical role in measuring the microscopic particles.